Welcome back, students. So today we are going to solve our last question of the paper that we started earlier. It's May-June 2023 of 9701 and the variant is 22. So in our previous videos we discussed about question 1, 2, 3 and 4, and today we are going to discuss the last question of the same paper. So we are proceeding. If you miss the previous videos, so I will attach the link to the previous videos of the same questions of the same paper, so that you can easily access. You can find the links in the description. So now this is the last question, which is the 5th question of the same paper, and in first part it says describe structural isomerism. So how we gonna describe it, or we gonna define it? Simply remember the isomerism, the structural isomerism, we can say molecules with the same molecular formula but different structures or arrangement of the atoms. So what we can say, molecules with same molecular formula but have different arrangement of atoms, or in short you can say different structural formula. So this is the definition or description for the structural isomers. Next part, here he says that A and B are structural isomers with the molecular formula C5H10O. Remember, C5H10O, whenever you see following the general formula CnH2nO, and in that case we can say it could be aldehyde or ketone, mean carbonyl containing compound. Furthermore, if examiner mentioned that the compound has two functional groups or different functional groups, then it couldn't be any aldehyde or ketone. So then we can say it's alkene and alcohol. So remember that. Now in the next part he says they are both straight chain molecule with only one functional group. So he negates that concept that this is containing two functional groups. So now we can easily say this is aldehyde or ketone. Okay. Furthermore, he is also helping us to give some positive tests to confirm the presence of carbonyl groups and then to confirm the presence of aldehyde or ketone. What are those? Here in the table these tests are given. So first of all, he added 2,4-dinitrophenylhydrazine, which is shortly called as 2,4-DNPH reagent. And remember, this reagent is used to check the presence of a carbonyl group, C double bond O. So if the orange precipitate appears, then it confirms the presence of C double bond O. So in A and in B, both there is a C double bond O, so A and B both are carbonyl compounds. Then the Tollens reagent is used to confirm the presence of aldehyde. If it forms a silver mirror, this is a positive test identifying that A contains what? A contains, or A is what? Aldehyde. But B, there is no reaction, it means B is not an aldehyde. When there is a carbonyl group but it is not an aldehyde, then we can say it is a ketone. Secondly, the next test is alkaline aqueous iodine. Remember, this is to check the presence of, let me show you by drawing, this is to check the presence of C double bond, CH3 C double bond O. So there are three different situations. This test is going to check the presence of CH3 C bond double bond O, or it could be CH3 bonded C bond O. But as from the previous two tests, it is clearly that we have this situation. We have the carbonyl group, not this one in this scenario. So what we can say, that the reaction, no reaction of alkaline aqueous iodine, that confirms there is no such thing in our molecule. There is no such thing in our molecule. So later it will help a lot. So keep this in mind, and we will see how examiner is involving these tests in the upcoming questions. Let me proceed. Here he says, name the functional group present in both A and B. So we predicted it is a carbonyl group. It is what? Because of the 2,4-D and pH giving us the orange precipitate, confirming the presence of carbonyl group. So what we can say, either in, has clearly mentioned name, so you can't use formula. So you have to say carbonyl. Carbonyl functional group. Second, then he says draw the structure of A and B. As I clearly mentioned, both contain C double bond O, both have 5 carbon atoms, and then there is no CH3C double bond O. So actually it is confirming the presence of carbonyl group. So in our both situation, the carbonyl group is not at the position of second carbon atom. So as the first one, the A was aldehyde, so I'm going to draw like this, C double bond O bond H. So this is aldehyde. Secondly, he says that there are following the general formula, or the molecular formula was C5H10O. So now confirm that how many carbon atom further we have? 1, 2, this is CH2, then CH2 again. How many? 1, 2, 3, 4 and 5. So this should be the structural formula of A. Next he says that, he says that the structures, usually when examiner is asking for the structures, then we have to prefer the displayed formula. Try to open all these bonds. Or you can write, maybe it is acceptable, but my advice is to follow the structure indicates the formation of a displayed formula. Formation of what? Displayed formula. Let me open it here. So it should be then C H H, then C, here H C H and finally CH3, like this. So you have to show like this, 1 2 3 4 5. Yeah. Next he says that the B was not aldehyde, so it definitely ketone, because both A and B having the carbonyl groups. So if there is negative test for the what we can say Tollens reagent, then it's what? A ketone. But remember, the carbonyl group must not be at carbon 2. So if we have 5 carbon atoms, like 1 2 3 4 5, so the carbonyl group is not at this carbon atom and is not at this carbon atom. So definitely what we have left with the choice here, so the carbonyl group of the B is at this position. Now rest of the bonds should be completed by placing hydrogens. So this should be the final structure of the isomer B. Hope you understand that. Okay, so now proceeding, the question is this part is over. In the next he says that C is a structural isomer of A and B. So mean have the same molecular formula C5H10O. But C is straight chain and has 2 functional groups. So now the same part which I discussed earlier, that the C5H10O could be a molecule with two functional groups, and those functional group must be alkene and alcohol. Then he says that C show only one type of stereoisomerism. So reminder for you that stereoisomerism we have either optical because of the chiral carbon atom, or we have cis trans because of the carbon to carbon double bonds. But he's clearly mentioning that we have two functional group, but our C is showing only one type of that isomerism, stereo. Either it is optical or it could be cis trans. Now testing giving us 2,4-DNPH, no reaction, confirms there is no carbonyl group. There is no carbonyl group. For the bromine, remember this is used to check the presence of double bond usually, because in AS level, okay, in A2 there is a different test as well, but as we are in the AS, so we have to predict this is only for the alkene. And as orange color is decolorizing, coming or changing into colorless, it confirms the presence of carbon to carbon double bond. Then another alkaline aqueous iodine that I clearly mentioned is used to check the presence of CH3C bond O. Now this time I could not say that carbonyl group that is attached to second carbon atom. No, we can say the oxygen atom that is connected to the second carbon atom. So we can say it is secondary alcohol, indicating what? The secondary alcohol. So keeping the idea of all the testing, the molecular formula, and we can easily predict the structure. How? We can predict, as I clearly mentioned, aqueous alkaline iodine confirms the presence of CH3, presence of what? CH3 bond C bond O. So this, because this is not but we can say ketone or aldehyde, so I can't write C double bond O. But aqueous alkaline iodine giving us a positive result, it means there is CH3CO group. So second, total carbon atoms are 5. Thirdly, there is a carbon to carbon double bond, which gives us the positive test with the aqueous bromine. So keeping all these information, we can predict the structure. How? That there is CH3 group, and then the OH group is at carbon 2 due to the conformation of aqueous alkaline iodine. Here is again H, and then if you clearly mention, this carbon atom becomes a chiral carbon atom, so showing what? Optical isomerism, as there are 4 different groups are attached. As we have to finish with the structure containing 5 carbon atoms, we have to draw 3 more carbon atoms, 1, then 2, and then 3. As one of the stereoisomerism is already shown, so we cannot show another type of the stereoisomerism, which is double bond. So if I draw the double bond here, then this carbon atom or this molecule will show cis trans isomerism, which is the second type of stereoisomerism. So I'm not going to place the double bond here. Then if I place the double bond here, this will also show cis trans isomerism. So that means the double bond position is not this. Okay, so finally we can place the double bond here, because due to the attachment of 2 similar hydrogen atom, this will not show stereoisomerism. Rest the structure will be look like this. And now we can easily say this is the formula containing, or total formula is C5H10O, containing 2 functional group, which is alkene and alcohol. This part confirms that the aqueous alkaline iodine confirms there is what? CH3CO group, and the bromine test confirms the presence of double bond. And from the instructions we learn that there is only one stereoisomerism, not the 2. So that's why we place the double bond at this position. I hope you get it. If not, you may raise any question, any query, whichever you have in your mind in the comment section. So I'm proceeding with the next part. Here he says that name the type of stereoisomerism. As I clearly mentioned, because of the chiral carbon atom, it is showing optical isomerism. So the answer for this is what? Optical isomerism, or just write optical. Optical isomerism. Clear? Now, next part, here he says D reacts in presence of sulfuric acid catalyst to form E and water. So no clue for us starting with this statement, so no need to worry about. Just remember that the reaction sulfuric acid is what? Behaving like a catalyst, clearly written. Furthermore, water is produced an extra product. So whenever we have this situation, that type of the reaction is called as condensation reaction, a process or the reaction in which water is produced, that could be termed as what? Condensation. Keep that in mind. Furthermore, this compound shows us the presence of carbonyl, and that is attached to bond O, so it is ester. This is what? An ester bond. This is an ester bond, this one. So he says that name the functional group present in E, so I can easily say it is ester bond. Second, I hope you understand that. So it means esters are formed when sulfuric acid is behaving like a catalyst and extra product is produced as a water. So it means this is this formula that contains how many carbon atoms? 1, 2, 3, 4, 5. There are 5 carbon atoms in total. So I can say 1, 2, 3, 4, 5. To this carbon atom, terminal carbon atom, there is an acid group. There is what? An acid group. And next to the terminal carbon atom, to the other terminal, there is an alcohol. There is what? An alcohol, OH. What is going to happen? These two terminals, like the H from here and the OH from this part, they are going to condense with each other, producing water, and then this molecule turned into a closed chain molecule, giving us the structure. So this is basically our D. We can say it is our D. Maybe examiner asked in our next parts that discuss or prescribe or identify the structure of D. So remember how we can get the structure of D. Is that clear? Now proceed. What are the original questions? So see, it's asking about the structure of D. He says identify the type of reaction that occurs when D reacts to form E. The evidence I showed that the production, the formation of water indicates that this is what? This is condensation reaction. And then I predicted the structure earlier, so you can write the exactly same structure here. Let me quickly draw. Maybe someone of you may get distracted, so I'm clearly mentioning here. So as I told you, there are 5 carbon atoms, 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. To the first, this terminal or either this terminal, it's up to you. You have to draw an acid functional group, and next to the second terminal you have to draw what? An alcohol functional group. So what they will do, the OH from here, the H from here will removed, producing us, giving us water, and then they will condense with each other, giving us this type of this structure. The O, like I can say O from here, will combining with this part that is containing C double bond O. Rest we have 1, 2, 3, 4 and then 5. But that part is condensed, so we will have the structure of the E. structure of E, like this. But you are supposed to write only this part. You are supposed to write only this part in your this. But as it is saying structure, so try to convert this into the displayed formula. Next part, let's we see what it is. So it's IR, infrared spectrum of the same compound E. Remember, E contains two functional group. The one was, E contains only one functional group, that is ester. Okay, E was, but the D contains two functional group. The one is carboxylic acid, the other one is the secondary alcohol. Keep that in mind. Now he says the given or the bond absorption. Okay, this will help you to explain your choice or your answer. Then he says use figure table to predict two differences in the absorption above 1500 of infrared spectrum of D compared to E. Explain your choice. So let me bring the table in front of you so that I can easily comment here. Okay, let me keep the question in front of you and keep the table. Simply I'm writing both of the structures of D and E. D and E. What was E? E was an ester with this type of the structure. Understood? Containing only functional group, that is. So if I break it down, what I have this absorption that appears as C double bond O, and we have another absorption which is CO. But remember, the CO, this is carbon with a single bond that is here, but its value is lower than 1500, so we are not going to comment on this part. Then I'm going to draw D. D was 1, here it was OH, then 1 2 3 4 5, and here I drew what? The carboxylic acid group. Now we have two functional groups here. One is a carboxylic acid. The carboxylic acid, again two main absorptions. One is C double bond O, but remember this is due to the acid. One is O bond H, again due to the acid. And again there is another OH group, but remember this is due to the alcohol. So we can comment on all these absorption. 3 from D, remember this was D and this was E. So 1 you can comment from E and 3 you can comment from D. So what you can say? Just say that in E there is absorption at the region here due to the ester at the region of 1710 to 1750 due to the presence of C double bond O. How you can comment here? Like you can say there will be absorption at 1710 to 1750 of C double bond O of ester. Same one comment. Second, you have to say there will be, I'm copying the same pattern, there will be absorption at, so again C double bond O, but because of the carboxyl, see the carboxyl is here 16 at 1670 to 1740 of C double bond O of acid or carboxylic acid. Now the third comment you have to write that there will be absorption of here OH group of carboxyl at the region of 2500 to 3000, and The fourth comment will be there will be another absorption of OH at the region of 3200 to 3600 due to the OH of hydroxy or the alcohol. You may not write hydroxy, you can write alcohol. So this is the comment. And looking at the number marks of the same part, if there are 2 marks, then 2 comments are enough. If there are 3 marks, yeah, okay, sorry, here it is clearly mentioned, predict 2 differences, predict 2 differences. So 2 comments will be enough, but I what we can say, prefer to write all the 3 comments, okay, from the D and 1 from the E. So that will give you the full marks, hopefully. So the paper, let me see, is finished this question or not. Yeah, so 2 marks only, and the question is over here as well, and the paper finishes as well. I hope you understand whatever we discussed during these questions. No doubt you can see the description is going in more depth, in more detail. But remember, as I am explaining each and every part, that's why it's taking more and more time. But when you got everything, you can finish your question within 5 minutes. But the important part is that you must have all of the information that is relevant. Understand? So I hope and I wish that you properly understand this, and all my efforts will be successful, and you may get good grades in your upcoming exams. Wish you all of the best, and inshallah in our next video I will try to solve one practical paper for you. So stay tuned, stay connected. We'll see you, and we'll upload the new video related to the practical exam inshallah soon. Take care.